Hi, welcome to the next video in the series on calculus and differentiation. This video kind of relies on you watching the previous video, which is on 5.4, which is the chain rule. So if you haven't watched that, I guess I encourage you to tread with caution because I do kind of make some assumptions based on that video there. So make sure you go have a look at that one first. So in this video, we'll be looking at the differentiation of exponentials, or exercise 5.5 in your textbook. It's actually relatively simple, and it's actually quite amazing how this works. This only works for the exponential function. So any other index number, so like 2 to the power of x, it won't work for, and 3 to the power of x, it only works for e to the power of x, which is quite amazing. And I can show you actually how they get this a little bit later in class. Or you can even do some research on it yourself if you want to. Just sort of Google derivative of exponential and find out why this is so unique. But you don't need to know why it's so unique, you just need to know how to do it. So that's where we'll get to now. If you've got an exponential, y equals, say, e to the kx, when k is just a constant, the derivative of this exponential is just k, so the constant, or the derivative of the top, multiplied by e to the kx. So the actual power doesn't change in any way. So if it was e to the kx before, it remains e to the kx. We've just multiplied by the derivative of the power. Okay, and I'll show you some examples about that in a second. The other thing I will mention is that the chain rule still applies in this case. Let me start on a simpler question, because the next couple I've got are a little bit more tricky. So imagine you've got y equals, say, e to the 6x. Okay, the derivative of this this function here is just going to be 6e to the 6x. Okay, so whatever the derivative of the top, which is the derivative of 6x, is just 6, and then we don't touch the power stays the same. Okay, so let me show you a more challenging one down here. I've got f of x equals e to the power of x squared minus 4x. So I'm actually going to use the chain rule for this one because I have a function inside another function. For example, e to the x is my outside function, and the inside function is x squared minus 4x. Okay, so I'm going to use the chain rule to get the answer to this one. So I'm going to say that u equals x squared minus 4x, and then I've got y equals e to the u. Okay, so then I'm going to get du dx and dy du. This is the chain rule, and I'm going to get 2x minus 4. That's fairly straightforward. This other one, and now this one is where people make lots of mistakes. The derivative of e to the u with respect to u is just e to the u. For example, if you've got y equals e to the x, the derivative of e to the x is just e to the x, which is quite amazing. This is the thing that I was trying to talk about before. So when I get the derivative of e to the u, it remains e to the u, and then I can get the derivative, the total derivative using the chain rule. So dy dx equals du dx multiplied dy du, and that ends up being 2x minus 4, all in brackets, and that's another place where people lose marks because they don't put the brackets in. Hopefully you won't make that mistake. Multiplied by e to the power of x squared minus 4x. Okay, so that's how we would use the chain rule in this case. Let me show you another example that again needs the chain rule. So I've got e to the power of 2x plus 1, and the 2x plus 1 is all cubed. I'm going to say that u equals 2x plus 1 all cubed, and y equals e to the u. If you can, try and get this to be the right hand side, so y equals e to the u. Try and make that e to the u. Don't leave it as e to the u cubed, because I feel like you'll just make mistakes with that. Try and make that one e to the u if you can. Now, as you can see inside this one, I'm going to actually have another chain rule, because even though this is a chain rule here, have a look at this one. I've got 2x plus 1 all to the power of 3. I'm actually going to need to use the chain rule again, unless you want to expand it out and do it that way. So what I'm going to do is I'm going to actually use the chain rule again. I'm going to say that v actually equals 2x plus 1, and then so u equals v cubed. Okay, and then I'm just going to go and do that again. So dv dx is going to be 2, and du dv is 3v squared. I know it seems complicated, but it's just kind of using the chain rule inside the other chain rule. So it's like a double chain rule, if you like. And then, so what I'm going to get is du dx is going to be 2 multiplied by 3v squared, which just becomes 6v squared. okay, which finally becomes 6 multiplied by 2x plus 1 all squared. Another way of looking at this is to say we multiply multiply the power down and then minus 1 from the power, so that'd be 3 multiplied by that and then to the power of 2, and then multiply by the derivative of the inside as well. Okay, so again, it's the derivative of the outside multiplied by the derivative of the inside. That's essentially what we've done. That's what the chain rule is. Now, this here, I need to remember that this is actually du dx. Okay, I still need to find dy dx. So du dx is du dx multiplied by dy du, which is 6 2x plus 1 all squared multiplied by e to the u, and then u is actually that one up the top, so it becomes 6 multiplied by 2x plus 1 all squared e to the power of 2x plus 1 all cubed. Okay, hopefully that makes a little bit of sense. Again, if you've got any more questions, please send me an email. Thanks.